Hello guys, in today's grade 12 physical sciences momentum and impulse exam clinic, we're looking at a question paper from KZN. This is their physical sciences paper 1 exam of September 2024. So the question on momentum and impulse was in question 4. And what we are going to do, first things first, let's all look at it and see that indeed this question, when you look at it, it's 12 marks. So what we are going to do is that we are saying we will spend 12 minutes into this question. Of course, I will try my best to also explain where I need to explain. Okay? But 12 minutes is sufficient. Remember, 1 minute, 1 mark. Let's see now. A truck of mass X traveling at a velocity of 20 meters per second to the right on a straight horizontal road collides head-on with a car of mass Y traveling at 10 meters per second to the left. The collision between the vehicles is inelastic. I want you to highlight inelastic, it's very key. The vehicles stick together during the collision and move to the right. The vehicles have a combined mass of 2,300 kilograms and a kinetic energy of 258,750 joules. 4.1. State the principle of conservation of linear momentum in weight. So it says the total linear momentum of an isolated system is conserved, isn't it? The total linear momentum in an isolated system is conserved. All right, is conserved. 4.2. Calculate the speed of the vehicles after the collision. Do you guys get this? Calculate the speed of the vehicles after the collision. So what we know, check this one out. After the collision, we know the kinetic energy. So with regard to the kinetic energy, we know kinetic energy is half times mass times velocity squared. What is the kinetic energy? 258,750. And then what is the mass? It is the combined mass of the objects, which was 2,300. Now, do we know the velocity? No, we do not. We leave it like that. Okay? Now, this basically says we have 258,750 equals 1,150, right? Isn't it? So let's see. 0.5 times 2,300, it's 1,150, correct. So 258,750 divided by 1,150, what does it give us? It gives us 225, right, equals V squared. Therefore, we can say V equals 15 meters per second, isn't it? So final velocity, maybe let me just say final velocity. Yeah, let me say final velocity. Okay, so final velocity equals 15 meters per second. Okay, final velocity is 15 meters per second. Now let's check 4.3. 4.3, ooh, for 4 marks. Show by means of a calculation that the truck has a mass of 1,916,67 kilograms. So you and I, we know mass of the truck plus mass of the car is 2,300. Mass of the truck is called X, mass of the car is called Y. So this is equal to Mhm, mhm. So, because we are looking for mass of the truck, let's just say wherever I see mass of the car, I will be seeing 2,300 minus x, right? So now let's get to our let's get to our calculations. We are now headed to using law of conservation of momentum. I will say to the right is positive. Okay, to the right is positive. Remember, even if you say to the left is positive, it's still okay. You will get the same answer. Okay, so let's see. So we are proving that the mass is this. Okay, so let's see. Mass of the truck plus mass of the car multiplied by the final velocity is equal to mass of the, rather, all multiplied by final velocity. Mass of the truck times mass, no, no, times velocity of the truck initial. Then we put it like that. Mass of the truck times initial velocity of the truck plus mass of the car times initial velocity of the car. Right? So what is this part here? This part here, we don't have to waste time. We know that it is 2,300, isn't it? It is 2,300. And what is the final velocity? We got it to be 15, right? And it was 15 in which direction? They said they stick together and move to the right. So it's going to be positive 15 because we said to the right is positive. Mass of the truck is x. And what is the initial velocity? It's 20 meters to the right. So it's going to be positive. Mass of the car is y. And what is its initial velocity? Sorry, it's 10 meters per second to the left. So it's going to be negative 10. Okay. So what do we have? 23, 2300 times 15 will be 300 and no 34,500 equals 20x minus 10y. Now we did say that wherever we see y, we're gonna put 2,300 minus x, isn't it? Yes, here is it. This is what we said, right? Okay, moving on. So moving on, we have 34,500 equals 20x minus this will become 23,000, and this will become 23,000 plus 10, oh boy, plus 10x, right? Plus 10x. Now let's see. 34,500 plus 23,000 will be 57,500, isn't it? Will be 57,500, isn't it? And then let's see. 57, this becomes 57,500 equals 30x. Therefore, x equals 57,500 divided by 30 will be 1,916,67. Therefore, mass of the truck is, in fact, we can leave it here, but let me just say mass of the truck is 1,916,67 kilogram. Okay, and this is exactly what we were supposed to prove. 4.4, let's see. 4.4 says, hence determine the magnitude of impulse experienced by the force. It's okay. We'll just say change in momentum. I can say this. Let's just say this. First things first. You need to state a direction you want to be positive. So going to the right is positive. That's very key. Okay, guys? That's very key. So I will say impulse is change in momentum. What is it? It is mass, open brackets, final velocity minus initial velocity. What is the mass of that truck? It is 1916.67. What is its final velocity? Oh, it was 15. And its initial velocity, what was it? It was 20 going to the right. So it simply say minus 20. Now, 1916.67 multiplied by -5. What do we get? We get minus 9,583.35. Therefore, our answer is 9,583.35. Be careful because this is impulse. You can say Newton second. Okay. Even if you write the units as kilogram meters per second, it's still okay. All right. The reason I'm leaving it like this without giving direction is because the question said magnitude. All right. So this is it, guys. So see you next time. Bye bye.